You have a question on what? Okay. So law of multiple proportions says it's also possible for two different compounds. I need this in bold. It's possible, I can't spell, possible for two different compounds to contain the same elements. But these elements will have different proportions. Which is why they're different compounds. They might be very similar or they might be very different. Carbon dioxide, really not very harmful to us. It's around us all the time. Carbon monoxide, not so good for us. CO, CO2, not much of a difference. H2O, water, really good for us. H2O, 2 hydrogen peroxide, not so good. On the other hand, there's a whole bunch of different kinds of alcohols that we use for all kinds of solvents and different things in industry. Act pretty much the same. So a bunch of fuels we use, like propane gas for our grills, natural gas or methane for our stoves, gasoline for our car. Those things are all very, very similar. Fossil fuels, chemically, all look very much the same and behave pretty much the same. They're all really good fuels for burning and do a good job for us. So if we look at my example says an unknown compound has 120 grams of carbon and 160 grams of oxygen. Is it CO2? Well, one thing to keep in mind is that CO2, we just found out this is the ratio for CO2. So I'm going to bring that down here so I don't have to do all the work again. If I can figure out where I was. So CO2, we know the proportion is 32 to 12.01 or 2.66 to 1. So let's find out, is this CO2 or not? I have to take, when I set this up, I put the oxygen over the carbon. So I want to do the same thing here. I want to make sure I put the 160 grams of oxygen on top, divide by 120 grams. And when I do that, that's not going to be 2.66. That's going to be 1.33. So this is only 1.33 to 1. So it's not CO2. So a good question would be, what is it then? Here's how you find out. Here's like the next step, and we didn't make you do this. We will do this a little later in the year. That's why we didn't make a big deal about it now. But the next step for scientists is, if you find out it's not something, it usually makes sense to find out what it is. I mean, it's great that you know something it's not, but what is it? What I can do is when I look at these two, 2.66 to 1, remember this is oxygen, oxygen to carbon, and 1.33 is also oxygen to carbon, right? So what do you notice about carbon in each of these compounds? It's the same, it's 1, right? So this formula should still be CO. Oh, got my little, but it's CO, but it's C. And how much oxygen is there compared to the first one? It's half as much, right? 1.33 is half. Take 2.66 and divide by 1.33. So it's still 1 carbon and half as much oxygen. So 2 divided by 2, half of 2 is just 1. So this is carbon monoxide, or CO. And we can tell that by comparing it to the CO2. So not only do we know they're two different compounds, but you can use it to figure out the formula too. You don't have to be able to do that last step. That's just like the bonus for showing up tonight. That's what we use it for.